part B, completing the square. 2.4, giant section.
Oh, man.
Okay, so here's the deal with the theory behind completing the square. So let us say that you have this. You have, okay, so let's say you got, goal for today. First, I better tell you what I want you to learn. Number one, we want you to understand the geometry behind completing the square. Shh. Which you may think like, okay, that's cray-cray. No, there's actually geometry. You're actually completing a square. Like seriously, that's what you're doing, is completing a square. Understand the geometry behind completing a square. And number two, be able to use and describe the two applications behind completing the square of a quadratic. Shh. Niece, I have a viewer that's telling you to stop being that guy. They can hear you on the internet.
Oh, cool. What's up, Luke?
Which is ironic because it says we have 0 viewers on, but. All right, use and describe the two applications behind the completing square. Okay, so number one, what is completing the square? Okay, so this is kind of weird, but we're actually going to talk geometry. And I know this is like cray-cray, but in high school math, we just kind of drill stuff you have to do in your head. But I'm always fishing for math majors. What do we do in college to like convince you to stick with this math thing is we teach you how like the geometry, the algebra, and something called discrete math are all interchangeable with each other. So let's look at something like x plus 3 squared. He said, hey, x plus 3 squared. Okay, what does that look like? That's some distance x plus 3 on both sides.
Oh, we're looking at the box now?
Oh, yeah. Oh, I hate that.
Which we could break down into its factors. You guys have learned that x times x is x squared. That we'd have a length of 3 x's.
That is not nice. I just like it mixed up there.
Shh, guys, stop talking so you can understand. So you have a length x times x, which what's the area of x times x? X squared. You have lengths that are 1 by x.
What room are you in?
I'm in 503. There are lengths that are just 1 by 1. And you're really smart. What's 1 times 1? What's 1 times x? X. So I'm doing a bad. Shh, it's hard to think with you talking. So then we could divide this up. We could divide this up into a perfect square. Now, what components is it made of? It's made of an x squared. It's got 6 of these lengths that are 1 by x, because if you FOILed this out, you'd get x squared plus 6x plus 9. So there'd be an x squared, there'd be 6 of these, and there'd be 9, 6 over here, 3 over here, to make the geometry a perfect square. If you FOILed it out, you could actually make a perfect square, and what would the side lengths be on each side? They'd be x plus 3 by x plus 3. The problem is if you've got something like x plus 2 times x plus 4, we would have x plus 2 on one side. Oops, I need to make this side shorter. Guys, stop talking. If you had x plus 2 times x plus 4 and you FOILed it out, you'd get x squared plus 6x plus 8. The problem is when you did that, 1, 2, yep, sorry, 3. Guys, stop talking. I know there's people next to you. Manage your impulses. You're in honors. 3 3, 4, 1, 2. The problem is you don't have enough to complete and make an entire square. So we have to find this area right here that would make it a perfect square. X plus 3 times x plus 3 ends up being a perfect square. What are your side lengths? X plus 3 and x plus 3. That's kind of weird to think of a variable making a square, but it is a squared amount. It could be represented geometrically by a square. The problem is when you have two unequal areas, we can't get enough of these single digits to be able to make it a perfect square. So we have to be able to think, do we need to make a perfect square? Was equal to like 17, it doesn't factor. Quadratic formula does always work, but I think when a is equal to 1 and b is even, completing the square is actually easier to solve, especially if you have to get an exact answer and you do not have a calculator with you. If you get an exact answer and you do not have a calculator. So number one, understanding the geometry that like x plus 3 makes a perfect square, but two polynomials that are not the same do not make a perfect square out of it. But we could figure out how many of those little single digit cubes we need to be able to make a perfect square out of it. It's the geometry of the algebra. Okay, so what are we going to do? So first off, we're going to teach you the method to complete the square. Then I'm going to show you the two applications it's used for. Method to complete. Okay, the rule for this, and if your teacher made you in Honors Algebra 2 last year prove the quadratic formula, which I will make you do, this only works when a is equal to 1. So if a isn't equal to 1, at some point I will show you how we make it equal to 1. If a is not equal to 1, I'll show you how we make it equal to 1. The key I want you to know is this. This does the same as the quadratic formula. But it will give you an exact answer. So in other words, there's no need to like take the square root and go through that part. I would think that if you had enough practice at this, you'd forget the quadratic formula and just complete the square, because there's no memorization, you just have to solve. The problem is that a lot of math teachers are really comfortable with memorization and not really comfortable like why does complete the square work, so they just teach the quadratic formula because it's just something you have to memorize and throw numbers into. But I had a prof challenge me in college to never use it again and just use completing the square, and eventually like my light bulb went off that I was like, okay, I'm just going to complete the square. I don't have to memorize anything, and it's just using algebra. And for some higher level things, it's something we have to do anyways. Okay, so let's take a look at an example, and I'll show you how to do an example. Example 1, I've got x squared plus, how nasty, let's make this one nice and easy, plus 8x minus 17 is equal to 0. Real quick, check, does that one factor? No, you can tell because 17 is a prime, and there's no way 1 and 17 are somehow going to add to 8. Now, could we use? Absolutely could. We're going to complete the solve, and this is going to be its first use. Is to solve the equation. First use is to solve the equation. The second way is to convert it from standard form to vertex form. But the first use of this puppy is to solve. Okay, so our first step, I'm going to write our steps over here. Step 1, move C to the other side. Move C to the other side. Okay, question, what's the value of C in this case? 17, so how do we get it to the other side? Okay, so 17, so notice we're just left with x squared and 8x on this side. I'm going to leave a little plus and a blank spot, because remember how we had to find those cubes to make it a perfect square? I need to know how many cubes there are going to be, and that's where I do. That's where I'm going to leave some space for it. Step 2, I'm going to divide by a. Part of this is dividing by a did what? Nothing, because a is equal to 1, right? So then step 3, but like for the proof of the quadratic formula, you have to divide by a. If you don't divide by a or factor a out, one of the two, it doesn't really matter which one of the two you do. You won't get the correct answer from it. Okay, step 3. I'm going to take whatever b is, and I'm going to call it the new b, because it's possible you would have divided it by a. I'm going to take the new b, I'm going to divide it by 2, and I'm going to square it. Why is it a new b? Because you possibly could have divided it by a. That's why I call it new b instead of old b. New b square, new b divided by 2, and I'm going to square it, and then I'm going to add that value, which I call new c, to both sides. If you look back there, there is a senior picture that is, I think, in like a gray paper from a kid named Ryan Silva. I had him in pre-calc my first year teaching here. I think his is the one that has new C on it, because it was a mind-blowing moment in his math education. Yeah, and you'll learn QED here right after spring break. Yeah. Oh no, nope. Don't have a TA this period that's learned it before. Kinsey, do you ever TA for a class? You just TA'd for Algebra 1 last year, right? Okay. Yep. Okay, tell them I need to talk to them before 4th period. Who is it? Ask them who. Say Beckman needs to know who is this. Okay, tell them to come start a next period. I'll write them a pass to the next class. Yep. Next question. So I'm going to add that new c to both sides. Okay, so this case, what's new b equal to? Well, the same as old b, which is 8. So I'm going to take 8. I'm going to divide it by 2, and I'm going to square it. Now, you're really smart. Do I square or do I divide first? Divide. What's 8 divided by 2? What's 4 squared? 16. So I'm going to add that to both sides. Why do I have to do it to both sides? So I maintain equality, right? You know, if you and your girlfriend love each other an equal amount, and on this day you've increased 16%, if you're still going to be equal, the only way is if they also increase 16%, right? That's good advice for when you turn 22. And real quick, what's 17 plus 16?
That would be 13.
Okay, stop and check out. Questions so far? So there is some knowledge. What are we doing? We're taking something that's like this weird Tetris-y rectangle, and we're making it a square by finding out how much do we have to add to make it a perfect square. Kind of weird. To make this side a perfect square, we have to add 16 to this side. It end up being a perfect square. Questions on that?
Is that it?
No, we got to solve it now. Well, now we got to make it the perfect square, and then we got to solve it. Make it the perfect square and then solve it. Questions on that? Aliana, is that your hands up or no? Okay. 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 Left-hand side. Ooh, now here's where we notice some patterns. Factor that puppy and then say, where else was that number? Factor that puppy and then where else was that number? 30 seconds on your own. Ready, set, math. 30 seconds on your own. Ready, set, math.
They're on a field trip today.
Who is? We'll say, tell them to send Beckman a text message. Or ask if they're in any of Beckman's class.
You could just text this person yourself.
I don't know who they are.
You just sign up for their reminder.
I don't want all their messages.
You don't have to get
No
all that.
offense. I'm sure this is a really nice person, but I'm inspired all the time by just being around you guys. No, niece.
That's how I start my best. Like Mr. My lit teacher was sending me messages on like reminding me to do assignments and stuff, and I just text back at stop because I already did the assignment. And
Okay. What does that factor to? What two numbers add to 16 or multiply to 16 and add to 8? 4 and 4. So you'd have x plus 4 times x plus 4. And notice that's what you should get here is you should get that number squared, hence completing the square. Yay. Is equal to 33. Now notice, where was that number before? Where did 4 appear in this before?
before.
Yes, it's what you squared up here. So step 3, notice you're going to add that to both sides. And I'm going to put some things to notice over here. Plus a number squared You get x plus some number squared, which is b over nu b over 2. Whatever nu b over 2 is what this factors to. Now, why do I tell you that? Because sometimes this ends up being a fraction, and it's hard to like identify what two numbers multiply to like 9 over 4 and add to 3. Well, whatever nu b was divided by 2, that's what number's in the perfect square. Then last step, what do you do? Step 4, you solve.
So can we just like
5.
skip all of this?
No, you add new c to both sides. Then I put notice. That wasn't a step. That was just like something to notice what happens.
Just add that. Now you can just see.
All right. And now, what do you do to solve this puppy? You take the square root of both sides, which means you need to consider what? Yeah, so x plus 4 is equal to plus or minus square root of 33. And notice, I should have wrote this down here. You take square root of both sides. That was a Beckman sin. Plus or minus square root of 33. Notice with that, the nice part of this is you don't really end up with all over to a. It works itself out in the problem. Square root of 33, I asked, does that simplify? No, 33 is only divisible by 33. 3 and 11, are any of those perfect squares? Nope. Then what do? Minus 4. So you get x is equal to negative 4 plus or minus the square root of 33. Final answer. Final answer. Okay. That could be. She wouldn't be on the physics field trip, though. All right, stop and check up. Questions on that? All right, let's have you try one. Who hasn't talked yet today? Lauren Barnes, perfect. What easy or hard one? Easy one, fine. X squared plus, let's at least make the number big. 16x minus a 9 is equal to 0. Okay, real quick, does that factor? Sad panda, could you use a quadratic formula? Yes, but your jerk teacher says you have to solve by completing the square. Oh, I know who it is now. Solve by completing the square. Ready, set, go.
Who is it?
No, you can't. That's for them to know.
Who is it? Give us a hint.
She's a drummer. Go. Complete the square. Go. Work the math. Who cares about this? I don't know. Go, go. Don't worry about nonsense like that. Worry about math, the important things. The things that will keep you drug-free this weekend.
Did you say it's x plus?
No.
Yes.
Oh, gotcha.
Oh. I
Yeah,
have
just
the
a
answer. Answer is mine. Mine is answer.
I need to stop.
You got any games on that phone?
Yeah, bro.
What happened? Oh, good. Whew, that was scary. 8, 6, 7, 5, 3.
8, 6, 7, 5, 3, 0, 9. 8, 6, 7, 5, 3, 0, 9.
Back when you used to actually know people's phone numbers.
Come on.
Okay. Niece, is there anybody at the school you don't know, brother?
I don't know so many people.
There's a song. I love songs with numbers.
I just love numbers.
What did you guys talk about?
All right, volunteer to come up and show.
I don't want to watch that.
Volunteer to come up. Brenna, as you're coming up, I'm going to give everybody a really hard one, though. Now we run into the train wreck. The train wreck, example 3.
Yay.
2x squared plus 7x minus 1 is equal to 4. Oh,
Now we actually have
now you, what's that? not square root of
This is
73.
so easy. You want to know why?
Why? Because you learned it last year. Mrs. Bravo did an amazing job, and you remembered everything she told you.
No.
You learned- I mean, how many people remember doing this last
Divide
year?
that by 2, and then you're doing it. And you're
Well, are you going to retain it now? Yes, because Declan's going to drill it into your head.
Yes.
Well, I tried. I tried.
Divide by two, that's dumb.
This is like home.
This is disgusting.
Who said that?
Probably A.
Me,
I'll be that guy.
7.5.
Oh, yeah.
So you divide by 2. And it's 7 squared.
5, 7, 3, 9, 6.
Just.
I called the AC75 It was like an insurance company.
That is actually, that's a number that people pay a lot of money for. Because like, if it was 719,
That is
8675309, people remember.
No, we can do this.
The phone company charges different amounts of money for different phone numbers. Like, if you want a number that ends in 00,
It's like commercial, like if you've done Super Bowl.
Yeah. absolutely. That's an asset to the phone company. Those numbers are good. Is that 719-765-309? Okay. All right, Brenna, can you explain what you did on this one, and then I will work this cray one up here for you.
Yeah, so I put the C on the other side, so I got x squared plus 16x plus blank is equal to 9. And so I divided b by 2, and then I squared it, so I got 64. So x squared plus 16x plus 64 is equal to 73, so I added 64 to 9. And then I square rooted both sides in order to solve it, and then I got this is equal to negative 8 plus or minus the square root.
There's something subsea. I was thinking,
All right, let's look at this awful one. All right, awful, terrible, hard. Now, this one's hard because what?
It's not hard at all.
A is equal to what? 2, right. Which bad news about 2, that means we're going to have what? Fractions, right. We're going to have a new b, and we're going to have fractions. It's just awful. Yeah, okay, first step, what do? I still add c to both sides because I'm isolating my variables. So I have 2x squared plus 7x is equal to 5. Bad news, 5 isn't even a perfect square. I then divide everything by what? Yeah, I divide everything by 2 because completing the squares algorithm only works with a is equal to 1. Don't listen to other teachers that tell you different. They try to take some shortcuts out of it. It only works if it's 1. It definitely doesn't work if it's negative, because you can imagine real quick, going back to that geometric application, imagine telling somebody the side lengths are negative of your square, and they fired you before you even finished that sentence. They're like, we can't have people that think this working for us, ever. But we give you a great letter of recommendation for our competitors. Yes, we built a bridge with a negative side length. Okay, now we take 7 over 2. We have to divide it by 2 and square. The nice part is half of 7 over 2 would be 7 over 4, right? So 7 over 2 divided by 2 is equal to 7 over 4. 7 over 4 squared, square the top, square the bottom. So we're going to add 19, or we're going to add 49 over 16 to both sides. Guys, don't talk. I got about 30 seconds left.
I did this in a way easier than.
Niece, what did I just say? Okay, now common denominator of 16 and 2 is 8. So I multiply both of these by 8. That gives me 40 plus 49, so I have 89 over 16. Now the good news is the top is nasty, but the bottom is not. What is this factor to? Right, whatever you squared. So you don't have to figure that out. Whatever you squared is whatever the factor comes out into. And then, well, what, Michael, brother, got to give you your money's worth. Take square to both sides. What? You do. You work. You pay taxes, brother.
I know, but I don't pay me math class.
Yeah, you do. You do. Okay, minus 7 over 4 from both sides. X is equal to negative 7 over 4 plus or minus the square root of 89 over 4. Final answer. And the good news is,
How'd you get over 4?
because what's the square root of 16? Right, when you have a square root of a fraction, it's square root of the top over square root of the bottom. The denominators always work out the same. Always work out the same when you complete the square. So there's some nasty parts to it, but there's some parts that always work themselves out fairly nicely. We will convert it to vertex form on Tuesday. Have a wonderful weekend. Don't forget about basketball today. Yes, I'll text it out. Hold on just a second. I got to stop the broadcast so the internet can be fun again.